You've seen it 100 times in school labs. Maybe sitting quietly on a metal stand while a science teacher adjusts the gas valve. With careful hands, a small blue flame, steady and focused, flickers above a short metal tube. It's so ordinary that you almost forget it has a name. But here's the part most people never think about. Why is this little flame-making tool called a Bunsen burner, and who exactly was Bunsen? The name sounds familiar, almost like it belongs to an inventor or a scientist from a long time ago. Yet most of us never pause long enough to ask where it actually came from. The truth is, the Bunsen burner didn't get its name because Robert Bunsen invented it from scratch. The story is far less straightforward and much more fascinating. In a way, the Bunsen burner is a tool that carries a name only half deserved, attached to a man who didn't even design the device's first version. Instead, the name comes from a mix of improvement, timing, and how history tends to remember certain people more clearly than others. To understand why this small laboratory burner had such a specific name, we have to travel back to the early days of chemistry labs, when scientists were still figuring out the best way to create a clean, hot, and predictable flame. Before Bunsen stepped into the picture, laboratories struggled with flames that were smoky, inconsistent, or simply not hot enough. Most early burners relied on simple oil lamps, candles, or crude gas jets that didn't properly mix fuel and air. Imagine trying to do delicate chemical experiments while your flame sputters, throws off soot, or refuses to stay at one temperature. That was the reality for early chemists. They needed a flame that wasn't too yellow or too smoky, one that could burn hot enough to heat substances without contaminating them, and that, surprisingly, was not easy to achieve. So let's go back to the mid-19th century, to a world where gaslighting was beginning to spread through European cities. Laboratories, too, were starting to experiment with piped gas. With these new gas lines came the possibility of a flame that didn't rely on oil or wick burns, but without proper engineering. Early gas flames were still weak and unstable. Chemists needed something better, something smarter. They needed a burner that could mix gas with just the right amount of air before combustion, creating a clean blue flame that reached high temperatures while remaining easy to control. Enter Robert Bunsen, a German chemist known for his sharp mind and even sharper interest in spectroscopy and experimental chemistry. He was not alone in his fascination with improving laboratory tools. In fact, the first version of what we now call the Bunsen burner was created by another scientist named Michael Faraday, the famous English physicist known for his work in electricity. Faraday had experimented with controlled gas flames decades earlier, designing early burners that mixed gas and air to produce cleaner combustion. But his design didn't fully catch on in laboratories. Later, in Germany, a chemist named Peter de Sauger took Faraday's ideas further. De Sauger worked as an instrument maker and technician, and he created an improved burner that could mix the right amount of gas and air automatically. Before the flame emerged, his design allowed the flame to burn hotter and cleaner, and it became a useful piece of laboratory equipment. De Sauger's burner was practical, reliable, and much closer to what chemistry students use today. But de Sauger's name never became widely known. This is where timing and association come in. Robert Bunsen needed a reliable burner for his experiments on spectroscopy, the study of how different elements emit unique colors of light when heated. To study these colors accurately, he needed a consistent blue flame that would not interfere with the readings. So he worked with de Sauger, who built the improved burner based on prior concepts. Bunsen did not build it himself, but he did help refine it and used it extensively in his research. And because Bunsen was already a well-known scientist, his name became attached to the tool his lab popularized. It's a bit like how certain inventions are named after the most famous person connected to them, rather than the person who did the initial work. History tends to remember big names, and Robert Bunsen's reputation made the burner's name stick. In many ways, you could say the Bunsen burner is named not because he invented it, but because he championed it, improved it, and used it in a way that made it essential to chemistry labs everywhere. But let's slow down for a moment and picture What makes the Bunsen burner different from earlier flames? Instead of relying on a wick or uncontrolled airflow, the burner uses a metal tube with an adjustable collar near the base. When the collar opens, air is drawn in and mixes with the gas before combustion. This premixed air allows the flame to burn hotter and cleaner. When the collar closes, less air mixes with the gas, producing a softer, yellow flame. The design is incredibly simple: no electronics, no moving parts, no complicated mechanisms. And yet the physics behind it is surprisingly elegant. The idea is based on a principle known as the Venturi effect. When gas moves quickly through a narrow opening, it creates a pressure difference that pulls air in from the side openings. This blending of air and fuel improves combustion, producing a flame that is both hotter and more stable. It's the same principle that makes certain carburetors work, or helps perfume spray from a bottle, but in the mid-1800s, this was groundbreaking. For laboratory work, think about how often students today rely on that familiar blue flame. It warms beakers, melts small samples, sterilizes equipment, and demonstrates everything from convection to flame tests. In many ways, the Bunsen burner became a symbol of hands-on science. For more than a century, it was one of the main tools students used to learn chemistry, and even though modern labs now include electric hot plates, infrared heaters, and more advanced devices, the simple burner remains iconic because of its reliability. So if the burner is so important, why doesn't it carry the name of Faraday or de Saga, who contributed heavily to its development? The answer lies in scientific culture at the time. Bunsen was already a respected figure in the scientific community, especially famous for developing the Bunsen cell battery, which powered early experiments in electricity. His work in spectroscopy, alongside Gustav Kirchhoff, helped identify new elements like rubidium and cesium. Because of his prominence, anything associated with his laboratory quickly earned recognition. When students began to use the burner widely in Bunsen's classes, they naturally referred to it as Bunsen's burner, and once textbooks adopted the term, it became permanent. This raises an interesting point about how naming works in science. Many tools and discoveries are named not for their inventor, but for the scientist who popularized or refined them. For example, the Fahrenheit scale wasn't invented entirely by Daniel Fahrenheit, but his thermometers made it standard. The Richter scale wasn't created solely by Charles Richter, but his work in measuring earthquakes made him the name attached to it. And so, the Bunsen burner follows a long tradition of attributing names to those who helped cement her tool's legacy, even if they didn't fully invent it. But here's where things get even more interesting. Robert Bunsen himself was known for being modest, even jokingly self-deprecating. He was the kind of scientist who cared more about results than fame. In his lifetime, he rarely claimed credit for inventions. Some historians believe he would have been embarrassed to know the burner eventually carried his name, yet history tends to simplify things, and attaching a short, memorable name to a laboratory device made it easier to teach and standardize. Imagine a world where every chemistry teacher had to say de Saga Faraday burner or premixed laboratory gas burner. It doesn't roll off the tongue. Instead, the name Bunsen burner is short, simple, and easy to remember, and because Bunsen was deeply involved in refining its performance and integrating it into laboratories, the association became permanent. But the story doesn't end with history or naming. There's another layer to this tool's significance. The burner helped spark major scientific breakthroughs. With a clean flame, chemists could perform flame tests more accurately. They could distinguish elements based on the colored light they emitted. This led to early discoveries in spectroscopy, which eventually influenced everything from astrophysics to forensic science. You can trace a line from that modest blue flame to the tools scientists use today to analyze stars, planets, and chemical compounds in extraordinary detail. For students, the Bunsen burner became a kind of rite of passage. Many people remember lighting one for the first time, hearing that soft whoosh as the flame appears, adjusting the collar to change the flame's color, or learning the difference between a safety flame and a heating flame. These moments connect generations of students to the history of science. Even in modern schools that rely more on electric devices, the burner still holds symbolic value. It represents curiosity, experimentation, and the hands-on nature of learning. So why does the name matter? Because names tell stories. They carry pieces of history that often go unnoticed. When you hear the term Bunsen burner, you're hearing the echo of a time when laboratories were evolving fast, when chemistry was shifting from mysterious alchemy to systematic science, and when simple tools played essential roles in big discoveries. The burner's name is not just a label, it's a tribute to the era, the people, and the curiosity that shaped modern science.